Hello, in this video we will talk about some important notions in logistic regression. So they are called odds ratio, logit, and likelihood functions. So first, based on the previous video on logistic regression, so logistic regression is to estimate the probability or model the binary results. So we call the positive probability is P here. So in logistic regression, the P can be expressed as a division from 1 to 1 plus e's negative x times beta. So x is a series of explanatory variables and beta a series of parameters. So this is a linear function. So this term is the probability of the positive results of a binary experiment. And we model this binary experiment results using logistic regression. So this is quite clear. Just like in the clinical trial, we know the characteristic or explanatory variables of the patients. Then we want to estimate what's the probability for the success based on these patients' explanatory variables. So it is quite clear. And this is not a linear function for this probability expression here. Also, the linear function for the explanatory variables and the parameters. So next, we will see this function is this figure illustrates the S shape. So this is the S shape for the probability when x or explanatory variables function will be very large. So the probability will be close to 1. And the other side it will be 0. And we also often hear about the odds ratio and the log odds or logit. What is? The odds ratio is quite easy. It is just a division. Or we say odds or odds ratio. It's a division between positive probability and negative probability. So, for example, if we want to model the cancer ratio, cancer probability of the patients in the previous example. So we can call the cancer rate or probability is P. So this is positive. And the 1 minus P or the not cancer probability is 1 minus P. So this is called the ratio, odds ratio. And log odds is just the logarithm of the odds ratio. So we call it log odds. So log P divided by 1 minus P. So this term also is called logit P. So log odds ratio is logit. So this important notion. Log odds is logit. So what is a logit? So logit can be further tested and verified that a logit P or log odds ratio equals actually is the multiplication or product of parameters and explanatory variables. So this term actually, if we look at the first page, actually equals this part, x times beta. So this quote means the transpose. So x times beta is a scalar, which is the dot product of explanatory variables and parameters. So this term actually equals logits. So logit is the log odds ratio. Log odds ratio equals the product of the parameters and the variables or the explanatory variables or the patient's information. So this is a quite important relationship. And we transform the logits back. Then this is the probability. So with this term is the probability, right? 1 plus EZ. So this So the logits, this is the parts of the logits, which is the first page we have seen the probability. So this is the logits or log-odds ratio, and this is the probability. So probability equals 1 divided by 1 plus is negative logits. So this is logits. Logits also Z is explanatory variable times parameter. Logits also log-odds. So we just write Z equals parameter times X plus B. So we just here maybe a little complicated, but it's very easy to understand. So just understand Z is a linear expression between the explanatory variables or characteristic of the parameter of the patients. Then this is the parameter we want to estimate. The projection plus a scalar, this called Z. Z is also the log-odds ratio. Odds ratio is the probability division for the positive probability with negative probability, right? And this sigma Z, why we write sigma Z? Because sigma Z is transformation from a linear function to the nonlinear expression. So this is a nonlinear expression, but Z is a linear expression. So we write sigma. Sigma Z is the probability of the positive case, right? And another very important notion in the logistic regression, or say the multiple logit regression, is the likelihood function. So what is the likelihood function? Likelihood function is a function we call the loss function, which is used to be maximized to estimate the parameters of the model. So if we want to estimate the model, the purpose of the model is to estimate the parameters, right? So we have to use the loss function. And this is the logit. This is the likelihood function of the W and B. So these two parts is we want to estimate. And this is given the known explanatory variables. And what's the information should be included in this function is product. This is all the production from all the samples and their probability of the given X and parameters. Then we see this Y. This is the choice or the label. Is cancer is positive or negative? Is 1 or 0 like this. So usually this Y will be 1 or 0 in a binary choice model, a binary logistic model, right? So the production is the probability of all the information we have seen with the X explanatory variables and the parameters we want to estimate and the labels or the choice, positive or negative value, 1 or 0. So the probability of this actually is the sigma Z we have seen in the previous page, right? So this is the sigma Z's yi plus times 1 minus sigma Z 1 minus yi. Why we have to write this? Because actually this is only one part is possible. If yi is 1, if you observe the positive, so this part will be 1. So actually it's the sigma Z. But if yi is 0 or negative, not a cancer, so this part is 0, right? 0, but this is 1. So this part will be included in the production. So it actually is one part is 1 and times another part is the probability. And this probability is either positive or negative probability. So it's quite simple. We just times or project all this information from all the sample. So this is called the likelihood function, and this function can be estimated, can be maximized or minimized to estimate the parameters. But you see, this function is quite complicated because this is all projection, multiplication of the old probability, and actually this probability is a nonlinear function. we have seen before. So in reality, we just use the logarithm of this function. So this function is called the log likelihood. We just use the small case, lowercase l, LWBX. So this is actually the same, just use the logarithm of this function, and thus the projection will be transformed as summation. And the yi, 1 minus yi will be transformed as the projection, not in exponential, right? In the power plot. So this is the likelihood function and include all the information we have seen. So this can be used to estimate the model, right? So this video we just simply talk about Logit, odds ratio, log odds ratio, and likelihood function. And one thing we take a look back. So this is the linear expression between the explanatory variables or characteristic of the people times the parameters we want to estimate, and this is a scalar. And this expression also are often called net input if we use the logistic in the machine learning. So this is the net input. Why we call this net input? Because this input is used in a nonlinear function. So this nonlinear function in the machine learning usually called activation function. So why we call this activation? So activation is just transform a linear part with a nonlinear part. That's why we use machine learning, and we can get more complicated model to estimate the parameters. Now this is machine learning's usage of this part we call the net input. And in economic model or econometric model, usually this part is also called utility function. So why we call utility? So this utility actually is individual get the utility from parameter and characteristic. This is just simple utility. So for example, if you make a model for the route choice in a transport, so this x may represent the different roads characteristic or quality. So utility here is just can be explained as an individual can get utility from which route to choose, right? So usually in economic model, econometric model, we call this utility. So this is actually the same thing, net input utility, right? So thanks for watching this video.